In this lesson, we're going to take a look at how to calculate molecular formula from data. Recall that the molecular formula is the actual formula for a chemical compound, while its empirical formula is the simplest reduced version of the formula. For example, the chemical known as glucose has a molecular formula of C6H12O6. Its empirical formula is reduced by a factor of 6, resulting in an empirical formula of CH2O. You can see by dividing each of the subscripts by the number 6, we get the simplest reduced version known as the empirical formula. Recognize that the empirical and molecular formula in this case are related by a whole number, the whole number being 6. Keeping that in mind simplifies this process to understand that the two formulas are simply related by a whole number. When looking at the question, it reveals the molar mass of the compound. The actual molar mass is 32.06 grams, equal to 1 mole, with the simplest reduced version of formula or empirical formula of NH2. Since the formulas are related by a whole number, the masses of the two formulas are also related by the same whole number. Therefore, if we make a ratio of the masses, it'll be the same whole number that relates the two formulas. Since we know the actual mass, we would always compare the actual mass, known as the molar mass, to the empirical formula mass. So I like to call that EFM. So we compare the molar mass in actual to the empirical formula mass. Our actual being 32.06. Our empirical formula mass comes from one N and two H's. Adding that, we get a total value of 16.03 grams. By dividing the actual mass by the empirical formula mass, we arrive at the whole number 2. The whole number 2 relates these two masses. It also relates these two formulas. Keeping this in mind, the empirical formula can simply be turned into the molecular formula now by multiplying by this whole number. Therefore, it creates an actual formula of N2H4. Our molecular formula would be N2H4. Let's take a look at one more example. Reading the problem, it says the molecular formula is what we desired for the chemical known as phosgene. It lists the molar mass, or the actual mass, as 396. Therefore, we make a ratio of the actual mass, or molar mass, to the empirical formula mass, accounting for 1 carbon, 1 oxygen, and 2 chlorine. This reveals an empirical formula mass of 98.91. By dividing these two values, we reveal the whole number that relates the formulas. This same whole number relates the masses. Since we're using the masses to generate this, this will arrive at the whole number that we need to relate the two formulas. Therefore, divide 396 by 98.91, and we reveal the whole number of 4. Since 4 relates the two masses, 4 will also relate the two formulas. We'll take the empirical formula and multiply each of its parts by 4 to arrive at the actual formula known as its molecular formula, C4O4Cl8.